Oh shit. No, that's not me.
And you did camera. So the equal 360 camera is pointing towards you.
What?
No, the camera only shows towards that. That table.
You see that?
Hello, everyone.
That camera is equal 360. The did camera it points.
Hi.
Bro.
Hi.
Oh my god, I did that a few times during lecture, bro.
Hey, over there. Hi. That works.
So you guys all go for capture.
So you may notice that I'm a little bit lower energy today. Got pajama pants on. Had a bit of an insomnia attack last night, so I didn't sleep at all, and I've been working all day.
I'm gonna get the
So it's going to be a very chill class.
I'm gonna get that.
Just kidding. I'm higher energy when I'm tired, so today's going to be the most energetic class for like 5 minutes until I pass out. All right. So ethics today. Everyone knows ethics, and we don't talk about it very much. And everyone knows that the first part of ethics is convolutions. Oh man, the mess is. I got it. So first up, let's remind ourselves of convolutions. I don't want you guys to forget it. It's important. So remember this case, we got a 34 by 34. That is a 32 by 32 with padding 1. And we're taking a convolution that has a kernel of size 4 by 4. And we're using a stride 5. Real quickly, remember, what should be the output size of this?
6.
6?
Yeah, 6 by 6.
No, 6 plus 1.
Okay, close.
Plus 1, 7 by
7.
7, yeah, close. It's a plus 1. The plus 1 always gets you. So it's this equation, right, which I want you guys to remember in some way, take a picture or learn it, I don't know. And it goes like this. Cool. Yeah.
How would we ever want to stride larger than the size of the convention?
Of the convolution. So the reason we might do that, short answer is that's kind of dumb to do because we're going to lose information then. We might want to do that if we care very much about the speed of doing the forward pass. Because you can imagine if I made you code this by hand. Ooh, horrible, right? And you would, don't worry, you're doing a computation, we'll move it later. And you would have to, go through every single place and do the matrix multiplication and da-da-da-da-da. And it'd be horrible. So you could have a higher stride if you want to do that. Or if you don't care about if certain filtered features are right next to each other, we just care if they're different, far apart from each other. And it's up to you to decide when to do that. Yeah. So the padding is just a layer of zeros. So if we have padding 1, that means we have an entire ring of zeros around the whole image. We could do it just widthwise or just height-wise. But it will be, that's why I have the times 2 in the calculation there, is because we have it on both sides. Yep. And they're just all zeros. Cool. And let's just do a practice one. This is a different one than last time, so you guys can't memorize it. We have 36 by 36 and a 3 by 3 convolution, and stride 3, this is padding 2. So this is a the image is normally 32 by 32, but it's 36 by 36 now. All right. 12? Yes. Nice, you get my praise. All right. Thanks. 12. Cool. Woohoo! All right, just try to remember these and try to remember that equation. On homework 3, which is released already, I don't know if anyone saw that, you're going to be needing to do this a good amount. So, maybe not actually that much, but you'll need to do it. You'll need to do it. So try to remember this equation or just be watching the lecture right now. All right, cool. It's already time for a quiz. So, someone from each group, come down quiz. You know the drill. Come on.
Thank you.
Nice.
That I stole from Ella yesterday. Yeah. Wait, so how did your tip break? What did you do? You drop it? I don't know. It's working now, but that's what matters.
What's that?
My pen stopped working a few days back.
Oh shit, I didn't count right.
Thank you. Oh, it's pen. Point of view.
And this fun change of pace. Quiz right at the beginning, so you get your blood pumping, right?
My heart is racing.
Yeah. Scary, right? Oh yeah, this one is going to be graded. Just kidding.
You actually scared me.
Okay, so 15 minutes is starting now.
2 in the chat, favorite activity. Cooper puts a quiz if he doesn't know what to talk about in production. I have no idea what this is.
How do you define is it without activation function? Yeah, that's what convolution is. Okay, so we are not counting activation function at all.
Well, it would be unreasonable because that's not what convolution is. Yeah. I got you, but any definition of convolution is not with an activation function.
Okay.
So this is how you get the size, the outer size, which is going to be 2 pi. Okay. So this is how you get the values.
Really heavy. Sorry? You get your breathing really heavy.
Quick clarification. So on the written response, when it says construct a case, that is essentially make an argument, use an example to make an argument. The most obvious way to do that would be to give data as an example. You can just draw data points if you want. That's what I do on the answer. by the way, the computation graph for the convolution should be in terms of plus and multiplication operations. And if you think that is horribly awful, I made it in Google Slides to give you the answer so you can manage.
Yeah. How do you define the sum of all matrix then? Like all the elements of the matrix? Can I write sum or like?
That's cheeky.
This is still true though.
I mean, if you're going to be using this notation, then you figure it out.
He said just like.
When you know too much about a graph.
About 5 minutes left, so.
I think you need slicing is sort of a secret, or you need some sort of indexing scheme. Okay. It's actually not that bad. I picked these sizes on purpose because the presentation got major presentation. Actually, not. It's a bit fast. It's not that bad.
that time. It's not quite 15 minutes, but I think people have gotten the idea. All right. Cool. Let's pop back here. So, you guys all feeling ethical?
No.
I was sort of lying, I guess. All right, let's go through the solutions, right? And have a little bit of chance to talk about this. Before I do that, though, I'm going to scare you all for a second. This class does have a midterm, and it is coming up soon. I think it's the 7th. Don't quote me on that. But it says on the syllabus, it is going to be in class on the Monday before break. And on the Friday, or not Friday, on the Wednesday before that, we're going to do a review. Yeah. What the midterm, what you should expect from it is basically this, but easier and longer, roughly. We'll see. I still haven't written it or anything, but we'll find out. Should be roughly like that. That's what I intend for it to be like. Okay, cool. So, first question. The point of using convolutions in a neural network is to change the dimensions of the data. And like before, I want you guys to talk to one or two people next to you and talk through your answer.
I think the
Do it.
is,
I mean, you can, but I don't think it's the main use of it.
yeah, exactly. I think the point of it is just to reduce the amount of data, but it's not to change the data.
Point is to extract features from the image. Extracting feature is dimension reduction. Maybe it is true.
Yeah, I mean, that is a side effect of it.
No, but you are extracting feature. When you say that,
It's more like you change the dimension of the data. That's like a byproduct of features.
Yeah, exactly. It's
The main point is learning the features.
All right. Let's get some thumbs up, thumbs down situation. If you think it's true, thumbs up. If you don't, thumbs down. Go. Just get a rough idea. All right. Let's see. It is not the point of using a convolution. I do put here that it can be a useful property. Sometimes we like the ability to do it. I suppose if you really wanted to, you could do it with that express purpose, but there are much easier ways to do that. The primary reason we do it is because we want to extract useful features. Remember before we talked about seeing little loops in our numbers? We want to be able to identify those and use those features instead of anything else. Again, you're going to be making a convolutional neural network in the next homework, and you'll get really acquainted with this idea. Cool. Next question. While using a linear model for classification, we decide to change the input to include the squares of each feature as well as the original feature itself. That'd be our new data would be x1, x2, all the way up to xm, but also x1 squared up through xm squared. This will allow our model to classify nonlinear data. All right, talking to groups. This one's a bit more of a thinker, I think.
I think it is false.
I'm not think it's false.
This
I
is
saw the big question. I was like, I'm not reading it. Like, I'm going to circle true.
I mean, it can be true, I don't know. I think it's false because if you had data which is like, goes like this, like in a line, and it has negative value, all of those negative values will become positive.
it's kind of like ReLU, but then it's like an absolute function, but then it's just doubling the value. So, and ReLU, if anything is lesser than 0, it just makes it 0. But this one is more like an absolute function.
So yeah, so the real data will remain like this and the new data will go like this. So there will be a point where the new data screws the original data.
That makes sense.
but that's my reasoning at least.
It does change the shape, so I feel like it could maybe put a different line.
I mean, even if you're like stuff like 1 to 10, let's just say like x is 1 to 10, the square will also have like, numbers like 1, 4, 9, so like that will also be.
Yes,
I don't think it will classify.
but the question isn't that will it classify better or not, it's will it allow our model to classify non-linear data?
I don't think it can. How will it differentiate?
I don't know. That's why I did false.
I don't know, but I'm inclining towards false.
I mean, if you scroll all the features, right? Let's say we don't do that. It's easier to tell apart 5 and -5, but if you like square that, now you have 5 and 25, and then -5 and 25. That's more similar than what your original case was. 5 and
Stuff
-5.
in a non-linear way.
Even if we take x and non-linear data, on the positive side, square of that would still be non-linear.
Right.
And we can't really like classify that if we don't use like a non-linearity mod, right?
Yeah, that point really comes up.
We're gonna say this, but it'll be on watch.
Yeah.
It's like, I got you guys. You guys forgot this one point.
I can totally see him doing that.
Did you think lambda is in C. Lambda function is what I was saying. There are C. I don't know. I think so. C++.
All right, I think that's about enough time.
Which one?
All right, thumbs. Go, do it. Oh, trick question. All right. So, out of curiosity, how many people who put their thumb down read it as all nonlinear data? No one's raising their hand. Oh, a couple people. It does not mean all. I did not say all. I said nonlinear data. And I could get why someone would say that, but does anyone change their mind then? I think you probably do, because there's no reason for you to say that if that's the difference. So, this is in fact true. So, to give a compelling example of it, we can have this data right here. It's a little bit hard to see the colors actually. But that middle clump right there is all purple, and the other ones are blue. If we imagine that right in the center is x equals 0, so this is a one-dimensional input, then if we were to have weights where we have 0 on x and 1 on x squared, then our model would exactly look like a parabola. So we've now seen that this data right here is very clearly not linearly separable, right? But using this parabola, we can separate it. So by taking the square of the feature, and in fact this would be true if we just squared the features instead of taking both together, then we can do this. This does not mean it can cover every case, and doing this is kind of like cheating. It's essentially like using a nonlinearity before we do anything else. We're squaring before anything else, which is a nonlinear operation. And this idea is called a basis. So we are taking a basis. This is actually a very small polynomial basis of the input. So if we were to take multiple other powers, and we also took x's cubed and x's to the fourth, and all of this, that would be, this also is a polynomial basis, and it does give us more power. Yeah?
Is that the same basis for linear algebra? Or is that
So, yes. So if you take in linear algebra, which some of you have, some of you haven't, you learn this idea of a basis. It is fundamentally the same thing. Essentially, we are increasing the number of bases that we have, and some of them are going to be squared. It allows us to get different things out of our linear algebra. Neat. All right. Yeah.
I have a question.
Yeah.
Can you explain once again how non-linearities are incorporated in that?
So they aren't exactly. So nonlinearities are not exactly how we've been defining them. Really, this is most properly defined as taking the basis of our input here, and we're taking a short polynomial basis of our input. What I was sort of insinuating is that we are still doing a nonlinear operation in our model. The nonlinear operation is squaring. You could think of it as part of our model that has no parameters. We are just squaring the input and then concatenating it. So it's very much like having a nonlinearity in that sense, but it's not exactly. You know what I mean? It's not the same as the other nonlinearities we use. So there's a reason to distinguish the two. Any other questions? This is a weird concept, and it's something that we've been hinting at slightly throughout. I'm being a little bit more explicit here, calling it a basis function. And you might have noticed later down the line we have the same thing. Something a little bit different, but similar. Anyway, third question. Convolutions can be used as a nonlinearity. Talking in groups?
Looks like false. Is it just
This will be a short talk.
Yeah, it is false. I think it is false. Because it's like, it's a linear operation.
You guys gotta circle one true, like in these true false. He doesn't make them all. Oh, that's
No, last one was all false.
Oh shit. Okay.
All three.
All three? Yeah. I had two as true at the beginning for no apparent reason. I had a feeling it would be true, and it was. But yeah, convolution can be used as a non-linearity.
All right, that's it. Yeah, I told you it'd be quick. You didn't believe me. All right, so let's do thumbs. Ready? Go. All right. Just get a sense of the vibe. They cannot.
Let's go.
So a convolution is made up entirely still of additions and multiplications. The entire operation itself, though it's doing it in a funky way, is essentially still just doing matrix multiplication. It's doing several of them, but it's still just doing matrix multiplication. As such, it is still a linear operation. So it cannot be used as a nonlinearity because we need that to be nonlinear, obviously. And that's the whole explanation. So now we get into the slightly more interesting question of this. So imagine we have some input, x, which is just some m features, x1, x2, xm. And we choose to create an augmented data set, x prime, which takes the sine and cosine of each feature. So instead of having the regular, we just have now sine x1, cosine x1, then sine x2, cosine x2, etc., etc., etc. This might be firing a couple neurons from when I was talking about bases earlier, is a basis. We are taking this operation beforehand to create a new input. This in particular is the Fourier basis. We're not going to be using it at all in class, but it is neat to know, and this does have some interesting properties. But the question was not that, the question was how we could have a case where the first data set as an input is solvable by a linear model can solve the first data set or the second data set, and what kind of things different? What sort of data would make sense to do that with? What sort of data doing this expansion would work for? And essentially, we get something like this. So similarly to how we had the quadratic, I'm going to use the same exact example to make a point here. We can do the same thing with a sine, right? So if we had sine of x, it would look very much the same as it's sine or cosine, whichever one. It would look very much the same, it would go up and down. So there are data sets where if we were to take the sine of that data set, it would allow us to separate it like this. You might be saying, doesn't that looks like the model, same as the other thing. Essentially what I'm doing is I am changing the model instead of the data, but it's exactly the same thing. So we have that, and then in the opposite case, if we were to have just a totally,
Then the question said it should be a linear model.
Yeah, no, so this is still a linear model. So it's still still just a matrix multiplication off of it. Imagine if this x on the bottom is our input, and we just take away on the sign of that one input, then we get a sine curve as our actual behavior of our model, which is why it looks like that. This is a square, but it's a continuate. Sines are really hard to do in this program, so just accept it. And then there are cases where we would have that this would not be able to classify something that just a regular linear model would. For example, if we had data like this, which is descending, right? So this is another separation. We realize that sine is cyclic, where it can't actually have a slope. We would only be able to have cycles that go up and down between 0 and 1. So that doesn't work. So there are cases where it is more powerful to have the regular, and there is times when it's more powerful to have the basis. Yes?
This is a bizarre question, but for
Yeah.
sine, since you have sine x1 and cosine x1, what if those just like cancel out?
We can have different weights on them. Imagine a case we have weight 0 on cosine. There. So what's interesting here, though, to note is that if we combined these, then we would be able to solve either problem. So by adding more of these bases, we are only increasing the strength of the model. This is a thing we can absolutely do with real data to do real stuff with. We're not going to be doing that, just to warn you all. I know it's horribly disappointing, but basically this is the entire idea, is that we are able to essentially pre-process the data in useful ways for us. Cool? Cool. All right, everyone seems really happy. Now time to be less happy, the computation graph. So, I'm going to do the whole computation graph, and I'm going to do it element-wise, no matrices, no cheating for me. So first off, I want you to realize that we have a 3x2 matrix as an input. We can represent that as just 6 inputs. I'm going to index them. I index them over here as 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Cool? Likewise, we can index the kernel, which will have 4 elements. I drew them up here so that I can get a prettier picture. And that is just K11, K12, K21, K22. And we know the output size because we all remember our equation. The output size is going to be a 2x1, which means that we have 2 outputs. All right, so let's start looking at this. So if we overlay them, this is how the operation actually goes. We multiply each of the terms that are overlaid with each other, so that one, that one, that one, and that one. Then we're going to sum them all together. So this is just doing a dot product over those operations, over those right there. And then that will become our first output. Likewise, we'll do the same after we move the kernel over. So now we will have a multiplication of this first kernel element with the second input element, and that one, and then those 2. The indexing doesn't make it natural to have it just move down 1, but we can do it like that. And then we take all of those, we add them together, and then we get our second output. So this right here is exactly a computation graph of this convolution. And this took like an hour to make, and I just got through it in 5 seconds, so everyone just stare and appreciate it for a second. Yeah. All right, enough of that. All right, so now the other questions. So the first question is, does the structure of the convolution, looking at this computation graph now, is there anything that makes it, what did I actually ask? I want to ask a different question. Does it treat any input pixels as more important than other pixels? So you can look at this now and think about it, and then I'll ask you all after like a second of thinking.
Yes.
All right. Yeah.
Because like if the kernel weights are, let's say, 0, 1, 0, 0, then it is emphasizing more on like second and third pixel and just getting rid of all other pixels.
Yeah, exactly.
The middle ones are always getting more priority. I mean,
It's not
they're
about
always
that, but
processed
if
more.
the build...
Anyone want to answer it? I think you were raising your hand, you want to go for it?
Yes,
Go.
I was going to say yes, because there are 2 layers that are calculated twice within the kernel, if we think about it as a 2 by 3. The second column is calculated in both of the majors.
Yeah, so we can see this explicitly on the graph. You see that 2 of the inputs, x12 and x13, I think, or 21 actually, are both used in both of the outputs. But all the other ones are only used in one of the outputs. So now we've essentially double counted these, albeit on different parts of the kernel, but still we've double counted them. So those are cared about more than others. This is an issue that persists in convolutions, so the more central, so I guess the more edge parts of your convolution will be looked at less. We can pad them to do that, yeah.
What if our stride is equal to the width or height of the kernel?
You still end up having so you still have one more use of everything besides, so you're saying the stride is equal to the size of the input?
Not the input, the kernel. So.
Oh, you're saying so it never overlaps. Yeah, no, that does work, although you need to make sure that it exactly can do it. If it can't, then it will overlap a little bit, but yeah, absolutely true. So if we were to have, in this case, if we were to have I guess not in this case, but if we were to have it so that it never overlaps with each other, we don't get that problem, that's true. But most of the time we do want it to overlap with itself because we care about seeing those features in more fine-grained detail. So those 2 are used twice, and that's not fair, and that does mean that we are biased towards caring about those. Now, secondly, on here, or thirdly, I guess. So looking at this and seeing what it looks like and how complicated it is in its own way, this is essentially a replacement of the dot products that we had before. This is a new operation, this is convolution. We can, later down the line, if you're drawing a commutation graph, just say convolution, it's fine. But for now, you can start to see this. And what might be a problem if we start increasing the size of our convolution? That is, increasing the number of filters, increasing the actual size of the convolution, and increasing the size of the input. What might be an issue? Yeah?
So because we're highlighting more, we're highlighting something more than the others, we may lose information.
So we can, hypothetically, so if we care more about certain things, so in this particular case, if we care more about these 2 pixels, it could be that we start overfitting to those pixels and we start not caring about other stuff. That's possible. I'll go with where I was going with this, which is, this convolution graph is a mess, right? Now I'd like you to think about something. How do we find the gradient of this? And let's imagine it is a much bigger convolution on a much bigger input with many filters. We see that we're actually getting, each one of these is going to be a summation of multiplications, and it ends up being pretty complicated. If we're going to do it the naive way of just doing back propagation, it is impossible. Not impossible, but very, very, very slow. But even if we optimize it, it still is fairly slow. So the issue is, if we have really big convolutions on really big data, taking the gradient is really slow. I'll make you guys perhaps like me a little bit more by saying I considered having you do convolution from scratch. It's not fun. I'm not going to make you guys do that. Don't worry. We're using PyTorch. We're using PyTorch. AutoGrad is nice. All right. So it would be very difficult to compute, and there are actually very clever linear algebra ways that we can calculate the derivative very easily. You can look at the AlexNet paper if you want to see the introduction of that sort of realm. And it's very interesting. But that is something we have to worry about. Convolutions are slower than fully connected layers per parameter. So keep that in mind. All right. So I did say it was an ethics class, right? So I think it's about time we start doing that. You guys remember these? Yeah, someone won, right? Yeah. So this is an example of one of the features from the Homework 1 data set. Right? What does the line of best fit look like here? Something like that, roughly, and maybe a little bit lower. I don't know. However you want to define it. All right, cool. That seems pretty clear what it should be. So then, similar to the question I asked before in the actual homework, would this be a good feature if, the y-axis is the value of the house and the x-axis is this feature? Who thinks that this feature would be a good feature to use to predict the price? Yeah, none of you guys? None of you guys think this is a bad feature to predict price? Or are you just worried because I called it an ethics class? So, it is obviously very linearly related to the value. That's clear. Any guesses what this might be? So it's something very related to the value of the property. Any guesses? We also notice that the higher the value of this feature, the lower the value. The higher the setting of this, the lower the value of the property.
Distance from the shore, beach.
Distance from the shore. Yeah, that's totally reasonable. Anyone else? Yeah.
How old the house is?
How old the house is? Completely reasonable. Yeah.
How old the owner of the house is?
How old the owner of the house is? Also perfectly reasonable. Yeah.
Did they encode race somehow?
Race somehow.
Yeah, I didn't want to say that.
Ethics, Tom. Come on.
Ethics, that's why.
Well, let's yeah.
The number of murders.
Number of murders. That's a good one. Yeah.
How close to the road, the main road?
To where?
The road.
How close to the road? That's a good guess. All these things seem like they'd be very linearly related, right? Well, let's look at the data set. I kind of hid what the features were for the homework, but let's take a look. Let's see. Okay, so what number was it? It was number 12. Let's take a look. Oh, it's the proportion of blacks by town.
I was thinking of saying.
That's not good. So, in fact, we see that the data set very legitimately does have a linear relationship between these things. Not great. And, in fact, looking at the homeworks, most people did say that these were linearly related, which they are. But that means that our model does care about this feature quite a bit, most likely, and it is using that as a metric to determine the value and weighing it pretty highly. So, now we get to talk about ethics. Oh yeah, I also want to show you this. This is not live coding. It is me showing you code that I wrote beforehand, though, live. So this is my solution to homework 2 with added code on the bottom. What I'm going to do first is I'm going to say that I'm going to take an input that is just going to be the identifier for a female. And I'm going to feed this into the model and see what it predicts.
Can you zoom a little bit?
Oh yeah, I can zoom. We'll give you features. I'm basically just describing what we're doing. So then I'm going to do the same, but just for a male feature, right? So this is the bit that identifies as female, identifies as male, and I did the same also with races A through E. So those were the features of the data that we saw from the live coding session. And I'm just going to plot what its prediction is for each of those. So let's take a look. Let it learn real quick. All right. So our model learned to predict that males would perform worse on all 3 of the categories.
Just sexist.
Yeah, it's sexist. Yeah. So that's interesting. Right? But how about the races? Let's take a look.
I'm a man.
By the way, since this is stochastic gradient descent, it does change each time. Sometimes it does tend to put males above females in just math, but males are always lower in the other 2. Interesting. And these are the races. Ooh, would hate to be race B, am I right? So the other races are all roughly equal, but race B is lower in everything. Yeah, not great, right? So this is a sort of quick and dirty way of me checking what it thinks of just these indicators. So this is just checking these weights. Particularly astute amongst you might know, though, that this is not a linear model. I'm using multiple layers, which means that the relationship is not necessarily exactly linear, which means just having this one indicator does not exactly say the whole story. So I wrote some extra code for you, just to show anyone who would say that, which I don't think was anyone, but instead, I wrote some code that will take all of the data that has certain indicators and average up what it says. So, Now if we run this, it will take all of the data and it will check for all of the data that had a female indicator, what was the prediction, average them together. It'll do that for every one of these same classes. So the first two images I'll show are from the old thing, so we can ignore them. Hey, look, male is better now.
Let's go.
So again, because of stochastic gradient descent, this can happen. It is fairly consistent on some things. I actually have not seen it predict male higher on these other two, so that's fun. But it is fairly consistent in some things. Again, race B is still fairly low, for example. But the other metric is going to be fairly consistent, and let's take a look at it. So, in this metric, this is more we'd see this the same way every time, is that males are very slightly ahead on math, and then females are much ahead on both reading and writing. And then in terms of race, we would see this. So in fact, it's race E that gets it in this. So that is partly because our data has fewer examples of race E, and they tend to be outliers. Because of our data, this is not exactly indicative of what the model is thinking, but it's a pretty good metric of it saying, race A is best race. So, yeah. Okay, so a bit to digest, and I'm sure if you ran this on your own models, very same results. It is definitely going to be biased towards certain races and certain genders, or sexes. So, now we raise the question, which is a bit of a weird question, which is, so first we can think, how do we fix this issue? But then before we even think that, we think, is this an issue? yeah, that's a thinker. So when we're using a machine learning model, right, so I'll describe first, when we're using a machine learning model, we are literally learning to statistically represent the data. We are getting the distribution and we are representing it. So we shouldn't really say that machine learning is not doing its job. It is. It just happens that there is absolutely bias in the data. And I mean, that's how we can do any sort of information analysis of our data at any point. But it also does mean that this happens. This is also not a particularly good argument for just letting it happen. It is pretty common for people to think, it is just the data, right? So that's just, it's not my fault, it's not machine learning's fault. It's just the data, that's just how the world is. So, let's think about if that is an issue. Is there any case where that would actually be an issue if we made a model that has this sort of bias? I'll give an example. How about that? Just to drive home the point. So, let's look at an example of predictive policing. Ooh, fun. Or even predictive incarceration. So, there was a small time or a small town used a machine learning program to determine the sentencing of convicts. As you'd imagine, it was heavily biased against people of color, various colors. Not white, though. And because of this, people of different races with exactly the same crimes were put in prison for different amounts of time. So, the issue is not so much that the model did correctly represent that, there was more incarcerations of people of color for various reasons. But using that model in this naive way was a big issue. That is very clearly racist and is not good. I think no one would disagree. Yeah?
Was the model just trained off of rulings from normal judges? Because that would make sense.
Yeah, so it was collected convictions and the sentencing time. Yeah.
Wouldn't it be more like the data the model trained off of was racist and not that the model itself?
So it exists. That is a reasonable thing to say, right? The problem is that we will always have racist data. And we have to learn how to deal with that data in a way that is reasonable and can avoid problems like this. It comes down to smart use of the data in the first place, and then smart use of the model. We're going to get to that, though. We're going to have a little bit of debating today. We're going to have a little bit of talking about this. So, how might we try to make sure that this doesn't happen? Give this a little bit of time to think. How can we make sure that it does not, say, predict that people of color should be in jail longer? How can we do that? Yeah.
Give really small weights to race.
Really small weights to race. I'll raise you one higher. What if we take race out of the equation?
Yeah.
Take it off the input, right? Yeah. All right. Let's think about that for a minute. In small groups, and decide if that's a good idea. Go, do it.
I guess prediction would be bad after we do that.
Yeah, I feel like if you're just using it to predict something, then you might as well put in race, because it does, like, as you should, have some kind of impact, but it's also probably just confounded by a lot of other stuff. And if you're using it to sentence people, then, like, you definitely just shouldn't have it. Like, I don't see the point in that, you know?
Like maybe remove races and like put other parameters and like, you know, the neighborhood they grew up in, or like that.
But then that indicates race somehow.
I mean, no, that still leads to yeah. If we put in other parameters like that,
Family income instead of race.
I mean, if you see the real data, isn't family income also
It's a very.
it is that is the data, but is the main driving factor behind our predictions, not actually the like in the real world. That's the main factor behind, like, you know, let's say housing costs. That might be the real factor, so we just keep that and remove the things which don't really matter logically. We can think about that.
All right, I'm going to cut it there. There'll be plenty more time to talk. That's what most of the rest of this is going to be, is you guys talking about your thoughts on all of this. But I'd like to get through this one because there is actually a pretty clear answer on this one. And I'd like to take it as a little bit of a teaching moment so that the rest of the discussion has some thinking to do. So, who thinks that it would be a good idea to remove the race feature? Just, okay, thumbs up for that, thumbs down for leaving it in. All right. So I think that is majority saying leave it in. I definitely bias people to saying that, but still, it's interesting to think about. If we leave it in, it is absolutely possible for our model to overfit on the race feature. We just saw moments ago, sometimes it is very easy to fit two. So we want to leave it in? Yeah, I'm biasing the other way. The answer is, yeah.
I was going to say, you use the race feature to reverse weight everything else.
So you reverse weight it. I'm not sure what you mean by reverse weight.
Yeah, like, because the race feature typically affects all the other features as well. You can talk to the race feature, but he's making an assumption.
So try to unbias it manually. So you look at how it's affecting it, and then you try to undo that. It's difficult exactly to tell how it's affecting, and not that you can't like calculate it, but it's difficult to do that. Not to say that it's impossible. Reasonable idea, and it does kind of get at the correct point, which is we do want to leave it in. There's two major reasons. One, if we take it out, don't you think for a second that gets rid of the relationship between race and result? There are lots and lots and lots of different indicators of this. Imagine we're looking at resumes, and we take the sex out of it entirely. We don't say, like, male, female, anything. But you notice that a lot of your candidates, or your model might notice, a lot of your candidates have 2 or 3 year gaps in their employment history. Well, maybe it was maternity leave. And maybe because you don't look at that, maybe you don't treat that sort of leave differently, you end up biasingly heavily against women. And this has happened. It was actually a real thing that happened. So there are lots and lots and lots of features like that. Think like policing, where you live, super tied to race. Again, race is very connected to a lot of things. Just taking out the race attributes doesn't do anything. But it does hide that your model's doing that. It doesn't let us do that test that we were doing before. So, what ends up being a bit of a nicer solution to all of this, not that there is a particularly perfect solution to any of this, is that we include the race feature, we analyze how the race feature affects it, and we essentially change the objective of our model, we change our loss function to indicate exactly what we want our model to do. If we don't want it to be biased against certain races, we explicitly put that in the loss function. And by doing this, we are actually able to optimize to not have bias against certain races. Woohoo, problem solved. Except it's not. The issue here then is that when we unbias something, we will, and at least there are cases where we cannot avoid biasing something else. So it becomes the problem that we cannot optimize to remove racism. Unfortunately, that's not the case. We can't optimize entirely for that, and even if we did, we'd end up introducing a whole bunch of new biases that are harder to see. So we have to essentially pick what we want to do. It's a difficult decision, and in models like this, where we're looking at our model that we're training here, it is difficult to decide, is it more important for us to be unbiased against race or against sex? Do we weight them? All of these questions are unanswered and are up to us to decide. Hence ethics. Anyway, with all of that sitting in, and I want to point out an interesting thought that the first time I heard this I had that I think is a good argument for acknowledging race, which is exactly the same way this model needs to be able to see the race feature, to be able to understand its bias of that race feature. I think so do humans. You need to be able to see race to be able to know that you're racist. Yeah. And we are all, same as these models, horribly biased. We are pattern matching machines just like these. So keeping that in mind, I think, can help you be a bit more of an ethical person. I think. That's total opinion now, but I think it's true.
So, when you modify the loss function in such a way that it's less biased towards like a race feature,
yeah.
So there's now more biases in other features. Is the bias increase like uniformly across all the other features, or a certain you can't predict that?
We cannot control it. So we can just prove that there are cases where unbiasing against something will rebias against something else.
Okay.
And what that is difficult, and it can be a hard problem. You can go through and really try to manually do this, but then the second you go around and do a new task, it goes out the window. You have to do it again. So it is a difficult thing to do. There's a whole domain of machine learning, actually. This is a difficult question. So it's something to think about. It's something I want you all to consider. And when you're making machine learning models, it is important to think about this stuff. It is so clear looking at this later that models are horribly biased. All right. So now you've had your medicine. Let's talk about something a little bit lighter, but still a big ethics question in machine learning. Should we continue to advance and use artificial intelligence and machine learning? I hope that we have a really biased crowd in here, but it is an important question that I think about quite often. So, I'll give you a couple of pros and cons, and then we're going to talk for a while about it. All right, let's look at a con, the singularity. If you haven't heard of it, you may have. This is the idea that when we have an artificial intelligence that can make an artificial intelligence that is better than it, that is smarter than it, then it would make it better and better and better and better and better and better and better. As much as this is science fiction and is, not important to think about, a lot of people consider, it is a real existential possibility that real machine learning people do think about. Researchers do think about this question because it is something that is an inherent danger of this process of creating intelligence. So, bit of a kind of moment for that. Secondly, we may be unintentionally or intentionally later down the line creating consciousness. We don't understand the nature of consciousness. We don't understand what sorts of things we should care about as thinking individual intelligent systems. So this is a difficult question of, should we keep trying? We're trying to create consciousness. We're trying to create intelligence. Should we? But on the positive side, we have that machine learning has very clearly improved the lives of humanity on whole. Through medicine, through entertainment, through everything in between. Machine learning is everywhere. Artificial intelligence is very important to society, the way we have it now. And also, another big positive is it's really neat. And this is a big selling point for me.
The same thing.
So I want you all, for like 10, 15 minutes, basically for the rest of class, I want you to consider this question, and I want you to talk to the people at your table about this question. All right? So give it some think. Figure out how you feel about this question. If you want to talk about the racial ethics and all this too, feel free. It's ethics time.
Should we go like one by one?
I personally want to destroy the world. I'm gonna go with yes. Next.
Creating consciousness is it moral? So I've thought of it. Yeah, I mean every single baby. Yeah, we have babies. Is it moral to have a kid? Is it? I don't think. I think it is.
That is a good point. Like, what if your kid turns out to be evil?
Yeah, exactly. Same thing. Just consciousness. Is it good to bring? Wait.
No, but like, what if?
I don't know. Exactly.
Yeah,
Giving it a mind to think on its own.
it does. Kind of.
Creating a kid
It is.
versus
I had this with
the machine you're making is for your own use.
So you are creating another conscious
I mean,
human
you can make it do
which
whatever
can
it
go
wants.
on to do bad things.
This kid and
But that's based on the nurturing, right? Like, is there a way to nurture the AI's consciousness?
Exactly. There would be. Yeah.
Is there a way?
That's the data.
It's not the same thing as making a kid.
Are you sure?
I feel like it's fine.
It just depends on which year you're living in. And which, like, you know, let's say you're a farmer in like rural India, and you're making a kid so that the kid can actually farm for you. That is the main motive behind farmers.
That is actually not true. Farmers don't want the kids just like, continue their generation or something.
Farmers make kids
Really down the
so that the kids can grow up to help them farm.
I thought
So the same thing.
So you're telling me farmers are the reason behind India's population?
without
Yes.
consciousness.
Is that what?
Yes.
I don't think that's the only of it. I think maybe that using protection is another reason as well.
Yeah, but like still, rural India, you know that.
My friend always refers to
Is it farming like a very dying down thing in India too? It's like not one of those.
Yeah, but like I'm talking about rural India. And that's
How big is rural India?
very big. Very big population.
Okay, how big? Like it's
500 million people.
rural India.
Rural India is like 80% of.
No, I'm talking about the land size, not
Yeah, 90% of India is rural India. Wouldn't that be called? That's crazy. Like 80 years, I mean, 90% of rural India.
and would make sense because it's not that big.
No, the population density is
But you could also argue that your benefit could also have long-term benefit.
What's your population?
Like, for example, like,
What's the population?
how many get a lot of kids for farming?
India,
and stuff.
1.4, I think.
I feel like the long-term goal for a family over the generations is to get a point where you're accumulating
I think it
wealth.
should be less than that.
Yeah.
That makes sense.
Yes. But then it puts them in a
That's survival, right? That's why. Isn't the point of life survival? And you want your
200 million and 1.4 billion.
It's like survive
300
over the generations. You can't do that if you're like in a constant state of poverty. So, you have a kid, you force him to go to medical school, and then, next generation, your grandkids are getting...
How does this have to do
I'm trying to say, like, how do you get, like, yes, it's inconvenient that, like, your mom is forcing you to go to medical school, but, like, you look bad, but, like, hey, your kids are rich now. I don't know.
it's about consciousness. Creating consciousness.
I'm like joking at the same time.
Has everything to do with consciousness.
Conversation, but, like,
What is your brain?
I'm still not
Your
sure
body
how I
itself
feel.
is just a
I don't
computer
know.
which thinks on its own.
Yeah, I'm just thinking of trading consciousness. How does that have to do with
you guys respond to?
See, I'm so bored of this.
How do you tell me how to do consciousness?
Yeah, you're basically forcing your kid to go to med school. Basically, you're forcing your computer to do something.
Wait, are you going to force your kid to go to
Yeah,
medical?
we don't know.
I mean,
yes.
whatever scenario you
Of
come up
course,
with,
I need free medical.
whatever scenario you come up with, where AI turns out to be bad, you can say the same scenario and come out with you having
Then we
kids.
can do whatever. Look, the entire point of consciousness is, like, you know.
So should you
What's the
stop
difference between
having
us and a
kids?
computer? To be honest,
By that logic,
that is way too much into philosophy, and I say
I
yes
feel
to your
like
answer, but
AI is better than
force animals to do so many
because
things, so
if
like,
you make a kid, it
so is
turns
it
out to
ethical to
be
make
evil.
computers do
You
something?
can't
we need to live, right?
just
So
kill
I think I'm
the,
working against
you
my.
can kill the AI.
Fair point, yeah.
You're just contradicting
Yeah, I don't know
yourself.
where I'm going, but like, so Adam, do you believe computers should be viewed as humans, like on that same level of humanity? We should view computers as humans,
like creative
like on that same level of humanity.
No, but we are talking about singular.
That's what I'm
At
saying.
that point, yes.
Consciousness, because like if we don't view them as humans, then like their consciousness shouldn't be taken into like that same level of humanity, right?
No, we are taking their consciousness to be kind of
Something like
more
what we're
than
doing right now, like bias and stuff,
that's
would
the
it be
whole
something
point of
which we
singularity.
want?
Yeah, I don't know.
Or would it
I
be
don't know.
something
We could go either way. If you're more of like humanitarian, go towards
itself?
no.
Yeah.
But if you want to advance society, go towards yes.
Yeah.
I don't know. I think I'll be dead by the time this actually becomes a problem, so I'm not gonna
Fully like independent AI, I've gotten everything really fine.
Or what if, you know, but what if the computer gets so advanced that it's able to resurrect humans and then you become alive again? And then you realize you were the reason for your entire,
Eternal Doom. Eternal Doom. Who knows what the world's gonna be like.
yeah, I mean, like, see, okay, you created an AI which starts getting better and better, right? And then you die, maybe 200 years, and AI starts getting better and better.
I don't know what that says about
You can or you can't. Everything is very. No, what if like puts every single, creates an exact copy of you? The AI gets to a level which like just exceeds that levels, then we are like like stupid animals to them. Right?
I'm just trying to get this homework too. If the AI can get this homework too done for me, like I will like be all for it, bro. Like
would that be evil in that regard? They won't think it's evil. We don't think it's evil right now, and most people don't.
oh god, are you coming to?
Even if you don't like instill whatever your personal needs are onto this
Okay, dude.
consciousness,
Well, I need to get this done.
that consciousness will still exist within your environment. That will still stabilize you're the product of our environment. Once that happens, you'll still know what's around it off of that. So either way, it's still getting a bias in you know what I mean by that?
Submitting the homework right now.
I guess like when you got imagining something which is like much higher than us. Exactly. Something like getting into that. Like it's conscious thinking, but it's not thinking like or someone who's like who has a greater thinking power than us.
No, I have to get up number 3 on the
For sure, it's like intelligent in some
Yeah.
aspect.
Wait, you guys are you gonna
Still not intelligent enough to be it could eventually become like small, right? It should still be conscious. You're not done
Let's say same goes for human and AI. Human is bringing in other conscious nature in the AI.
Okay, do you want the Terminator to happen in real life though? Like, that's the question. Do you want the Terminator to happen in real life though? Like,
Would the Terminator happen in
yeah, dude, like,
I don't think so. I took 220 last semester, and like
I think if they're
So you know what lecture I'm talking about. Like Marius's other professor, Kelly Puck, and did like a lecture on like robots, and she literally, and like,
they are
entire
physically
lecture
created
is a compilation
just to do
of like
certain
robots
tasks.
just like failing to do simple tasks. Like you'll try to open a door and just fall over. And her point of that was like, robots
I feel like if you were to create a
Just enough learning, bro. Like
only used to do
maybe like thousands of years of learning later. Who knows?
Then that's not similar. We are talking about.
I mean, why are we giving the robot thousands of years of opportunity to kill us?
Some point.
That's I don't know, bro.
You can just switch off the computer.
Ask the ML guys, bro. Ask the ML guys.
It's an easy fix. Just switch off the computer.
Yeah.
In the golden words of Dr. Otto Octavius, I'm sure. It says the same thing.
Yeah, you don't. You
There is no right answer.
Devil's advocate the entire time, but
To be honest, bro, I like the status quo, bro. It's not changed things, bro.
it's just like, just like the ethics of like highly intelligent, like highly intelligent like robots and stuff.
You better support it. You're going to get that PhD, right? You gotta do it.
Have you heard of the movie Her?
If you go against it, it goes against your whole like purpose of life.
Oh, that's why I'm creating it. That's why I'm creating it. I would be better in the eyes of AI than you guys.
But like, you know, my position is I've seen the creator guys first. Yeah, that's what I was about to say. The creator.
No, but other suppose like creator just dies.
I don't really know.
Other people suppose the AI.
Behind that is, but look.
AI comes to consciousness. Imagine you made a robot right in front of you. It has arms,
there has to be a
it just woke up and saw you.
I guess.
It doesn't know what
Something
you are.
related to the singularity.
It will
I've never heard of
instantly
that concept before. So
You're
that's
dead.
fascinating. The singularity just to the point where
Yeah, it's all dumb. Like at the end, it's like all the same questions. What's the meaning?
It becomes a philosophy debate. Yeah, that's what I'm saying. Yeah. I think it's like it comes down to if you look at AI as humans or not. If you don't, then like if they're not on the same level of humans, it shouldn't matter, right?
No, but
what if
like
you bring them
then it causes trouble to other people.
Because if you talk about that humanity debate, like how about animals having consciousness? Like whatever happens to that.
So why do you want to do something that causes trouble to other people?
Yeah, that's what I'm thinking.
Because before it reaches
Like that's what I think when it comes
point
to.
where it causes trouble, there is a sweet period of time where it is not.
Dude, how would we survive if everything had a if we like done like an ant, bro? We can't even step on an ant, bro. Like, what are you talking about? Like,
bro, isn't this like the vegan community?
I don't know. I like my chicken biryani, bro. So like, I'm good.
Can't eat it. It has thoughts and feelings.
That's what's gonna be the
Dude, I haven't had chicken biryani in so long. So if we get a chicken biryani, that makes me so hungry.
It might be true, and like his level of thinking, our thoughts might be like
When's the last time you had chicken biryani? It's been so long. I need to go home this weekend.
What is good Abu Dhabi this week once we get to
Oh shit. I thought it was like something with some restaurant. For a sec, what you say? You said Abu Dhabi. I was like, wait, what the fuck? I did not hear you fully.
We're trying to turn this into a philosophy class to make us forget that
Dude, if you saw the midterm question, yeah, no, it's right there. Oh, exactly. Dude, if these are like the midterm questions, bro, like I'll ace this, bro. Like, is all the AI continuing AI? What?
There's no meaning to anything like that.
I think I've seen a video of it. Just like
Forget about life and just move on to the afterlife.
Of course it does.
That's how
Stop it. Do not hit the camera, bro. I'm not trying to get exposed in 4K right now.
When you hit camera, that camera will turn around.
How do you know this?
But you can change that.
Yeah.
You have the control.
No, everybody does.
So if I open the camera over here, it will point to us and they can see us.
No, not there, but it will point towards you.
The more you learn, the more you don't know what the fuck we're doing. Yeah. Wake up and ask.